Hello and welcome to this training. My name is Daniel Richter from the Technical Department at Academy Americas. Today we're going to talk about the frog operator for swing gates. The frog is an operator for underground. The purpose of this training is to give an overview of the features, how to install it, the connections, and configurations. So we'll start right now. So I'm going to go do an overview. I always like to do an overview about a typical installation. Obviously, we have the operators. If it's only one gate, obviously it will be only one operator. The control board, this kind of operator need a control board to do all the connections that go in there. They basically do they know exactly where the gate is and do the slowdown. They're going to stop, give power to the operator depending on the situation. So everything is controlled by the control board, the electronic board. There's a remote control that's optional, but usually the client, the owner of the installation, they usually want a remote control or a few remote controls to control the gate. The selector is a wire selector. It can be buttons, it can be a keypad, it can be a key with a selector, anything that is wired and controls the operator. Warning light is optional, but it's recommended to have a warning light so it blinks to warn anyone close that the gate is moving. And photo cells, very recommend to have two pair of photo cell, one pair outside to cover that area if a car or a person interrupts the beam, and the gate is going to stop and open again in the cases if it's closing. And there's another pair that we recommend to put to the inside of the property. So also basically covering the entire area where if the car is close to the area where the doors open or close, if something is there, it's not going to open or close depending on wherever you put it and you configure that. I'll show later more the connections and all details about that. Junction box, everything is connected with wires and pipes. That goes to everything in the junction box. So basically, where everything joins and goes to wherever it's going to be. Physical stops. This is very important. We recommend to have a physical stop, something that actually stops the gate from closing beyond the normal point and for opening beyond the point that is normal. And this is because even though the operators that have their own stops and they have the switches and all that for safety reasons, we recommend having a stop that prevents the gate from closing beyond the normal point, or to prevent damages, or maybe closing too far and leaves something a gap to open so a person can go through. So basically, just make sure that the gate has something to stop and close, and the gate, when it opens, it has something physical to stop. And a courtesy light, that's a very optional, but you can propose that as a feature that just illuminates the pathway. You can configure it to be open when it moves and stay open for 2 minutes or whatever. That depends on the configuration on the board. And we also like to overview the danger zones. Just make sure to keep in mind those danger zones, maybe with electricity for electrocution, or maybe in the gate. Obviously, if someone is in the path, it could get injured. So keep those in mind. And now the selection criteria. There are many operators, many type of operator for swing gates, and you have to be sure to basically judge what operator to suggest, what is the best one. Today we're talking about the frog, but for example, you need to be aware of where it's going to be the application. In this case, it could be in homes, in multifamiliary condos, or in the industry or commercial applications. In this case, the frog, it can be continuous. It can work continuously, so it can work in either way. There are other kind of operators that they need to rest in between cycles. So those are not appropriate for a condo, for example. But you need to also be aware and consider the characteristics the site needs. But most importantly, it would be the type of door, the length, and the weight. Those are very important because each motor, every motor, have their limit or how strong it can be. So how long can be the length of the leaf and how heavy it can be. So you need to keep in mind those limits and be aware of the which operator you select depending on those weight. Obviously, you cannot weight. Usually, you cannot weight a leaf or the door, but at least the estimate has to be close enough to inside the limits. And later, I'm going to talk about more about that. And also the finals, the limit switches. Sometimes there used to be electronic operational delay. That's for timing. It used to be a knob. I say it used to be because it's not that common anymore. But by timing, it would be like you calculate maybe it takes to open 10 seconds so you adjust the knob, and after those 10 seconds, the operator stops. And it's not anymore, that's not used, but that's one way to the limits switches, limits of the travel. There's another with switches, actual switches. They can be mechanical or magnetic. And those are basically, if the switch activates for closing, it stops the motor. And for opening, the same thing. When there's another switch, you can adjust, and whatever hits the switch, then it stops. And there's another way to adjust the limits is with encoder. It can be optical or magnetic. And those encoders are basically a revolution counter. And when you do a calibration, that way the control board can know where the gate is. There's sometimes our operators have a combination of switches and encoders. This case, the frog we're talking about today is only uses switches. And I'm going to talk about that more later when we go to the installation. So again, doing a very quick overview of the operators we have. So all of them for swing gates, and there's an articulated arm. Those are very good for doors where the door is very far from wherever you're going to put the operator because they have a big articulated arm so they can reach farther. There's another type, worn drive, and on the right, those worn drives are aesthetic. Some people like it more how they look, and they have the advantages or disadvantages. But we're talking about the underground, and there are three types: the frog, frog plus, and super frog. Today we're going to focus on the frog, that is 24 volts. For all of them that are underground, basically how it shows here is underground, so it's basically invisible, and that's the main advantage. Um, but one thing you have to be aware is that there has a minimum distance between the hinge and the surface where it's going to be mounted. The minimum for the frog is 67 millimeters. So just make sure you have that enough space. If the hinge is too close, maybe you have to, when you do the hole for the operator, maybe you can dig a little to the column or wall, wherever you put there, is there. And but you need to consider that thing. This is the only like distance that you have to be aware of each operator. Each operator has their own limitation for that. It's basically the distance between the hinge and the surface. Okay, so just keep that in mind, keeping the limitation, the specifications. The limit can be depending on which operator you have. The Super Frog, for example, is 100 millimeters or 4 inches. The frog we're talking about today, the one on the first, is 67 millimeters or 2.6 inches. Very little, but you need to be aware of that. It's basically the distance for the hinge. And the maximum for this one is maximum 3.5 meters or 11.5 feet or 100 kilograms or 1,700 pounds. So those are limits for the leaf, but you need to pay attention. It's not that simple. I'm going to talk about that later. So basically that IP is 66.7. That means that it can be, since it's underground, it can be underwater without problems. And also there's not going to be a dust problem and it's not going to get inside. The casing itself, water can be there fine, but the motor itself is watertight, so no problem with that. And 24 volts DC, there's a version. So that allows to use emergency mode with batteries, or it can be used with solar panels. So on the ground for single family homes and apartment complexes, 3-4 volts, like I said, intensive use. So like I said, intensive use means that it can open and close continuously, and it's not going to get overheat. So that's why it's a good option for commercial apartments, condos, that kind of situation. So those are the limitations. It can open 180 degrees. That's another advantage. And it actually can open to the outside or open to the inside without problem. And the control card or control board, CLX24M and CLX24S. So there's two versions. I'm going to concentrate on the S version, but either of those control boards can manage the operator. This is the technical data. Like I said, IP67. Most relevant thing here will be maybe the power, 180 watts. That sometimes is irrelevant because they use solar panels, so they need to know if they're capable and maybe do the service. And this one is what I was talking about before. So let's, like I said, the limit of the leaf, it can be up to 3.5 meters and 800 kilograms, but not at the same time. It can be 3.5 meters, but maximum weight at that length would be 400 kilograms. And it can be 800 kilograms, but maximum length would be 2 meters at that weight. So just make sure you don't overpass these specifications. It's a common mistake, a common misunderstanding. We have a limit of those two, but it cannot be both at the same time. So follow this graph, this table, and keep that in mind so it doesn't go over limit. If the gate's too heavy and too long, then you have to choose another operator, maybe the Frog Plus, for example, depending on the situation, or maybe another type in general. So this is the parts. What comes in the box for the operator. And like I said, the operator is by itself, and also you have to buy the control board separate. Like it shows here, it's a casing, there's a motor. I'm going to do an overview. There's a movement transmission lever, and the motor just turns and has a lever to connect it to the main shaft, shaft and hinge that goes on the bottom. There's a cover. I'm going to show more later. So this is the magnetic end switches that I was talking about. They're adjustable. So there's a magnet in the main arm, and when the magnet goes close to the switch, it basically tells the control board to stop. It reached the limit. And the wall seal and protected color, that makes it watertight, and also dirt resistant. Door release, there's a door release in here. This is the main door. Basically, it's a key that you can turn it and release the door, and you can move it manually, even without power. So now we go through the installation. Obviously, you have to dig a hole big enough for the operator, for the casing. And this is just suggestion measurements, but you can be a little bigger. And actually, I suggest you do it a little bigger so you have more space to do it fits better in the ground. And it's very important to the base to be very secure to the ground. Sometimes you can a big nails in the floor on the ground, and that way when you put the concrete, it's going to be a very secure base basically. These operators produce a lot of force, so when you need to take that in consideration when you do the base. And another thing you have to do is obviously doing the pipes for the wiring. And also, this is an additional thing, they need draining, because since they are underground, a lot of water is going to get there, and since it's watertight, it's no problem. But the idea is that when the rain stops, there's a way to drain that water little by little. So that's why it has a big hole in the casing. So you put a pipe, sometimes they put rocks or any kind of thing that is going to help the dirt to absorb the water. So anything that is for drainage. They show here a box with holes. That's fine. Anything that helps to drain the water. So the dirty side, earth absorb the water. After that, you put the main case and do the concrete around it. Like I said, put it as much secure as you can. And the limitation here will be align the hinge of the door to the axis of the operator. It has a little axis where it's going to be. You need to align that as much as perfect as you can. That's very important to be super level. Some people use a little string with a weight, without a rock, and you can align it perfectly. And that way, yeah, they need to be aligned. And also the distance that I was talking about before is 67 millimeters between the hinge and the surface of the column. Obviously, it has to be level also in those two axes, and waiting 24 hours to the cement to secure. And after that would be the next day, we'll be putting the door again and well to the main shaft. Since it's aligned, no problem. This is the fixing for the motor. It can be in either side without difference. The only difference that you need to do is put this screw, this bolt, in this side or this side, depending on which side you install the operator. That's for the limit, physical stop for the limit for opening. So I'm going to show that later. Since you put the motor and then you put the lever arm, connection arm, it's good to put some grease or oil, so because it's two pieces of metal basically. And this is what I was talking about. So the motor has two bolts that you can adjust the position where it's going to be closed and when it's going to be open. For the open, there's this bolt and it hits the casing, and you can adjust it using obviously unscrewing the bolt. There's a nut to put it tight so it doesn't move. And same for close. For close, I had another one, but this one is in the main shaft of the motor. And the same way, it hits the arm, and you can adjust it to whatever position you want when it's close. So you need to adjust that. After adjusting those stops, now we adjust the limit switches. And this case is open and it's a little before the actual physical stop in the door, like I can show here. So the idea is that you open both doors if you have only one door, and you put it on the open position, and you adjust the switch so it's very close to the main shaft. And when it gets close there, it's going to activate the switch, and the control board later is going to stop. So adjust that for open, and for close, do the same. So there's two switches, one for close, one for open. They have a little screw that you can, when you get into the position, you can tighten it so it doesn't move. And then you can do the connections. In this kind of motor operator, it has basically 5 cables. Is M and N. Remember that you can take note of that. That's for the actual motor, DC motor, M and N. And actually, one of the tests we do is put a battery between 12 and 24 volts. You can put a battery there and see the motor should move. And you can revert that polarity, and you can move the other direction. That's one test we do all the time. And so remember, those M and N is the actual motor. And you see that the motor has all other cables. That's for the limit switches. And those are connected the way it shows here. If you only have one motor, the control board has two outputs for the motor number 1 and motor number 2. If you only have one motor for one gate, you will connect in motor number 2, okay? And in this graph, I show 2 motors, and it's the same way, but they have their own connection for each motor. And one thing to remember here is that the limit switches, they're connected between the common, that is in here is 2, and FA for open and FC for close. So limit switch for closing will be FC, and the limit switch for open will be FA, okay? That shows in the manual, so you don't have to really remember, but I want to overview. There's a case that you have to put at the end. Although I recommend you leave it open for the final adjustments, because sometimes we do the final adjustments on the final on the limit switches. This is the way to release it, like I showed before. It's like a little key and you release the door so you can open and close manually. So now we go through the control board. So there's two control boards. There's an M version and an S version, but they basically do the same thing. It's just control the operators. It can be one or two. You can choose either control board, but they have a little differences. Here's a overview of the differences. We did a training about those control boards in more depth, but I'm doing just the basic stuff for this training. So this is the differences. The M version is a little smaller. The display is a little different. The S version has a cover, and those they have the same connector. They have safety inputs. The S version has 4 inputs, and the M version has 2. That's 4 cells. It can be a loop, ground loop. So it has a time. The S version has a clock for doing timers. And the S version has an output B1, B2 that's configurable. But if you only need the basic stuff, the M version is fine. So these are the connections for and the motor that we showed already. And this is one thing that you keep in mind. So if you have 2 operators for 2 gates, and by default, they're going to have a delay for opening motor number 1 and a delay for closing and motor number 2. It's important because usually doors have they overlap each other, and so they need a delay so they don't hit each other when they're closing or opening. And it's very important because sometimes if you don't know, maybe you have to swap them, and so they do the delay in the reverse, depending on the situation and how you connect. Or maybe the doors don't overlap each other and you want to open at the same time and close at the same time. Then in that case, you have to remove this delay. By default is 2 seconds, I think. And in the menu, you can adjust that. So keep that in mind. That's all I'll do in the menu. Is the connections is the same for the S version and the M version, either control board. And doing our overview would be, so one thing to remember and keep note is that pin number 2 is always the common. And we use the common for many things. One of the things is to give commands to open or close or whatever. And this is what we're showing over here. So between 2 and, for example, if you do a pulse between 2 and 3, it's a normally open contact, and the operators are going to open. If by any chance they do the opposite, 2 and 3 is always open. So if you do 2 and 3 and it's closing, you know that is the motors are upside down. So you need to reverse the wires. And 2 and 4 is always closing. And if you do a pulse or a button or whatever you have connected, between 2 and 7 is open and close, open and close. And you can configure also to open, stop, close, stop. That you can configure in the menu system. So this is what is showing here. And this is the connection for the lights. And between 10 and 5, there's always voltage when the door is not closed. So it's 24 volts AC. And when 10 and 5 is very useful, sometimes we put a relay. And so it gives the position, basically you can see the position if it's open or closed the door. Between 10 and 5, there's always 24 volts, except when it's closed. When it's closed, there's no voltage. So another thing I wanted to always show is that between 10 and 11, there's always power. That's to power photocells. It can be a part of matrix. It can power external receivers, whatever you want, except they have to be inside the 50 watts limits. But that's pretty much, that's a lot. So remember that 10 and 11 is powered, 24 volts AC all the time. It becomes DC when when it's powered by batteries. Pin 10 will become the positive and pin 11 will become the negative. But usually normal operation is AC. And this is a connection for the electric locks. Those locks are for 24, that's for 12 volts AC. And it gives power just for 2 seconds to release the lock. If you need another kind of lock, you need a relay and an external power supply. This is the connection for the photo cell. And depending on your photo cell, there's a few differences here. But the main thing they require is just power. In this case, we give it between 10 and 2. That's the power for the photo cell. And they also give a normally closed contact. And that normally closed contact, like I said, always we use the common that is pin 2. And in this case, this has 4 inputs that you can configure. Usually we use CX, but you can use either. And remember where you connect it, and then you can enable that input in whatever option you want. Usually the option is C1. C1 is what is closing. If it detects an instruction, it's going to stop and open again. But there are other options depending on the situation, so you need to be aware of that. So it's the basic connection. And now we go to the programming. It's very similar in all operators we have with displays. The only difference is the display is a little different, but basically we use 4 buttons: escape for going back, left and right to navigate the menu and change the values, and enter to confirm values, and also to get to the menu. I'm going to show later an example of that. So the basic steps after you connect everything and everything is installed is tell the control board the amount of motors we have. So if you only have 1 motor or 2 motors, that's as simple as that. Or type, these control boards can manage all operators for 24 volts. Operators for 24 volts, including the frog we're talking about today. But then in that case, you need to tell the control board which operator you have installed there. So in this case, would be a frog, or it can be generic, depending on the situation. I'm going to talk about that later. Enabling safety devices. If you put a photo cell or a ground loop or whatever safety device, you need to enable it because by default it's disabled. And the 4 steps would be adding users. When we say user, we talk about remote controls, keypads. It can be a fob, a card, a proximity card. It can be anything. So you can add it. The next step will be adding those. 5th step, and basically the final basic step will be travel calibration. And that calibration is a procedure where when you start it close the gate and open. And when it opens, basically memorize how long it takes. If it has an encoder, it takes how many revolutions the motor did before opening. So that way it's going to do calculations and do a slowdown in a more efficient way. And exactly for the frog we're talking about today, we need to put the type of motor. One of the steps we talk about, the second step, would be there's very many options here. And this type of frog, you need to put it in generic. That generic allows you to have more options later for the limit switch. I'm going to talk about this one. Is the one I was talking about. So then when you put that kind of motor, generic, then you have the choice of doing what you want the limit switches to do. In this case, you can put stop in FA and stop in FC. Like I showed before, there's a connector that says FA and FC. And that means that if you detect the switch for opening, it's going to stop. If it detects the switch for closing, it's going to stop. Or you can put it in stopping FA and slow down in FC. It's basically what it says. If A for open, if it detects the switch, it's going to stop. And for closing, when it detects the switch, it's going to start the slowdown. So it depends on whichever you want. Usually it's this one, the last one, but you can adjust it whatever you want. And the last thing about those limit switches is that it can be normally closed or normally open. That's why we choose generic, because we wanted this option, basically. Most important, this option. There's another type of frogs that don't use these switches and they use encoders and stuff. So that's why it depends. And that's why I wanted to point out about this frog in particular. And this one in particular is normally open contact. So in inputs FC and FA, like I said, it's the input for the switches for open and for close. So make sure to choose normally open. This says by default normally open. Just make sure it's normally open. That option is in configuration and motor settings and input types, FC, FA. That's the name of the menu. Going to go through the menu now. This is a video I made for the Fernie. It's another operator, but it also helps for this operator that is very similar. So you get to the menu pressing enter, and you can navigate using the arrows. You can choose the language. It should be in English by default, but if you want to check out the language, you can do. And one of the first thing I recommend is going to configuration and going to the wizard. You can go to the right, or it's faster if you go through the left. And when you find a wizard, just press enter and you're going to start that. It's going to be a step-by-step procedure. And it's easier that way to configure the operator. That way, that's the wizard. You press enter. So basically, it's going to ask each step. And the first step we talk about is how the amount of motors we have installed. Only M2, it means only one operator. And it says M2, just make sure you connect it in. If it's only one operator, you connect it in motor number 2. Or if it's M1 and M2, I mean, you have 2 operators installed. In this example, I had only one operator, so I'll choose only M2 and I press enter. The next step is type of motor. And in your case, we'll have choose generic, like I said before, or frog, or whatever operator you have. And in this example, I have Fernie, so I choose a Fernie. And this motor check is very useful because if you hold the left arrow, it's going to open motor number 1. And if you hold the right arrow, it's going to open motor number 2. That's very useful because you can test if the motor is working, the wiring is correct. If, for example, you hold that and it's closing, you know that it's revert. You have to reverse the wires. So it's very good to have that keep in mind in this motor check. Now let's input CX. CX is the safety input that we talked about earlier. Usually you put photo cells, it can be any safety device. And so, like I said, it has many options, and the most common is C1, reopen while closing. That's the most common, but you have to choose whatever is good for the situation. And so I select C1 and press enter. There's another 3 inputs that I'm not going to use because I don't have anything on it, so I leave off. So I leave it off for CZ2 and CK. So leave it off and I use it. Add users, you can confirm yes or no. If you're going to add a user remote control, you need to install the AF card. And now you can receive remote controls. And now it's asking for the user mode, that is what you want the button to do. Step by step would be open, close, open, close. And there's a very popular one that's sequential. There's open, stop, close, stop. So whatever you want to do the button to do, just press enter on which option you want. Some people prefer just open, and there's a partial opening. For if you want to upload, there's a auxiliary. But the most common is sequential, so select sequential. And it's waiting for the code. So now it's ready for you press the remote control. Also you press it, save it in number 1, and it's ready to receive another remote control. And the last step will be travel calibration. So you confirm yes. And like I said before, it's going to close the gate. And if you have 2 gates, it's going to do it for both. Close and then open. And then remains open and it finishes the calibration. It's only basically going to learn the entire travel of the gate. As simple as that. There are many other options that you might want to change. One thing that you can do for testing is the left arrow for opening and the right arrow for closing. And the escape button you can press to stop the gate at any point. This is very useful for testing and doing all kinds of tests. But like I said, there's many options, and one of the things you might want to change is the speed of the gate for opening and closing. You can do that in configuration, run settings, opening speed. By default is 70%. So maybe you can change it to 100% if you want the motor to move at a maximum speed, and do the same for closing speed. You can also change the delay between M1 and M2, like I talked before. Maybe you put in 0 if they don't overlap each other. There's many other options. I'm just going to do the overview of the most common ones. There's another one for automatic closing that is in configuration and times. And then it's automatic close. And as I says, by default, this is disabled. You can set the amount of seconds that is going to remain open before closing automatically. Are there many other options? We did a training about this course already. So if you want more details, you can watch that. But at least for the basics, we covered the basics. And so thank you for your attention. And we always here to help. Remember, uh, um, we always giving technical support for problems. Sometimes, especially at the beginning when you install the first time or the few first time, it's always an inconvenience and you don't know really sure what to do. So remember, we always here. It can be by phone, email. We always giving support. We always giving training. So we're always willing to help. So just remember, we always willing. We're here. So thank you for your attention and see you next time. Bye bye.